Ice, water, and vapor. They're all the same, right? Well, kind of, but not really. They're all the same molecule, which is H2O, two hydrogen and two oxygen. We call it the building block of life. But in the laws of thermodynamics, it actually has a specific set of instructions to be in certain situations. Now, anything below 0 degrees Celsius, you're going to find yourself with ice. Ice forms exactly at 0 degrees Celsius and below. Now, ice is a solid. We know it's a solid because it has two things. It's got a fixed shape to it. I can pick up this ice block, and it will not change shape no matter what until it reaches 0 degrees. It also has a fixed volume. No matter what you do to this object, it will always be the same size and have the same amount of volume. Now, we have ourselves some water, and water is a liquid. Now, it sits just above 0 degrees Celsius. Right now, I'm sitting at 18 degrees Celsius. We know it's a liquid because it has two specific factors to it. It has a variable shape, which means I can take this water and put it in any other container I have, and it will always take the shape of that form. But, however, it has a fixed volume to it. This fixed volume means that no matter how much I pour this into other places, it will always have the same volume of 200 metric liters. Now, is this the same for everything else? No, it's not. I have another liquid here. I'm using rum, for example. It is sitting under 0 degrees Celsius. Yet, it actually has a variable shape, and it's still a liquid. Now, climbing up the ladder here, we have gas, vapor. If I were to boil this water here and make steam, it would have a variable shape and a variable amount of volume, which means I can compress, I can decompress said gas, and it would take up a different amount of volume in a space. Very disorganized in gas, very organized with liquid, and even more structured in ice. Now, I can show you an example of gas, which is called elephant toothpaste. It's a specific reaction with hydrogen peroxide, dry yeast, and dish soap. And what it will show you is just how variable gas in its form can take shape. Let me get our ingredients out and I'll show you. Now, before you, I have a old Smucker's squeeze bottle of strawberry jam, which that's definitely not what's in here. I have a cup of hydrogen peroxide, 3%, and a little bit of Dawn dish soap. I also added in some red food coloring while you weren't looking. Now, to make our catalyst here, we need a little bit of warm water and about 3 tablespoons of yeast. And I'll just eyeball it. We'll pour our yeast in. A little more than that. And we're just going to slightly mix it up. Now, this is going to be our catalyst for this experiment. And what I'll show you in this experiment is how gas is variable in both shape and size. We have this just about mixed up here. Get ready for the fireworks. Now, what's going to happen is a small chemical reaction from the yeast and the water forming what we call elephant toothpaste. Elephant toothpaste is a gaseous foam, which is significantly more liquid or more formation than what we saw. This bottle was only filled up to about here. Now it's all over this pan. That shows you just how variable the shape and size, or the shape and volume, is of gas. And this is important to know because gas is very important to us. Helium being one of the first elements, and hydrogen being the first element, both gases. Now, there are stipulations to these rules. Now, I have one of those stipulations in front of me, and that's called a non-Newtonian fluid. Now, non-Newtonian fluids have 2 specific states that they act to. They have the properties of a solid, and they have the properties of a liquid. Now, to create what we call Oobleck, or a non-Newtonian fluid, we have about 800 milliliters of cornstarch. We'll put that out in the tray, as we should, making a little bit of a mess. And we have half as much water that will pour into this. Now, after this, I'll have to mix it up. And I did add a little bit of food coloring just to kind of spicing it up. Now, Oobleck is important because it is actually both a solid and a liquid. When you slowly apply force to Oobleck, it will become a liquid. But when you actively press on it and use force fastly, it'll act as a solid. And what I'll just do is I'll speed up the mixing process. That way it doesn't take up too much time. Well, I'm not going to lie when I say that didn't get a little messy. Now, this is what we call Oobleck. The ingredients are variable depending on what's called for the specific environment. Sometimes cornstarch has a little more moisture and sometimes it doesn't. But in this case, I had to add a little more water to make it a little better to mix it all up. Now, this is what we call a non-Newtonian fluid. And to demonstrate that, I'm going to take this spoon and I'm going to hit it a couple times, see how it acts as if it's a solid, and it doesn't change its shape whatsoever. However, I can drop the spoon into the concoction. The spoon starts to sink. It's a little more firm than most Ooblecks, but you see how it's starting to sink around the edges? Now the spoon sank into the Oobleck because the Oobleck also has the properties of a fluid, which makes it a non-Newtonian fluid. I showed you before how it can be smacked and pushed around and it acts like a solid until having slow force applied to it. If I were to slowly pull the spoon out of the Oobleck, you would see that it has considerable amounts of liquid properties. You can see the Oobleck oozing off of the spoon right there. Pretty cool stuff. Oobleck, a lot of uses. A lot of it has been used in stress balls, body armor, any shock absorbing equipment. But the interesting thing about it is that it's just fun to play with. So to show you another example of why it's a solid and a liquid, I'm going to take a chunk of this Oobleck and I'm going to roll it into a ball. Now, this ball will act as if it's a solid in between my hands. As long as I'm applying force and pressure to it, it will act as if it's a solid. Until I slowly stop doing what I'm doing with it, and then it gets a little softer, and it gets a little softer, until I end up just stop applying force to it completely, and then it acts as if it's a liquid. And it will slowly take the shape of this form and stay like that until force is applied to it. Luckily, if you wanted to create this at home, Oobleck is very easy to clean off yourself. You can just add some water to your hands, rub it off, it's fine. States of matter are all around us. We see them every single day. Specifically with water, we cook with it, we drink, and we put it in our drinks so it gets colder. We use states of matter to our advantage every day. Now, I just showed you the examples of H2O, our very own molecule of life, but just think about all of the other molecules that we use day to day, like hydrogen peroxide. And I used alcohol as an example to show you that just because other things get below 0 degrees doesn't mean that it's going to also turn into a solid. Now, take this for what you will, and try it yourself. Try doing the elephant toothpaste or the Oobleck. It's very fun to be able to understand what's going on, science-based, of what we handle every day. When it comes to states of matter, I only just covered the big three, which is solid, liquids, and gases. There's 2 more which have been added on since I've been in high school. And the one is called the plasma, and the other one is a BEC on the quantum level. Very interesting stuff, and I appreciate you watching. Have a good day.